Good afternoon, my YouTube viewers. In this video, what we're going to do is we're going to perform a hypothesis test on battery lifespan. So the practice question that we have to go over is, a battery has a lifespan of 300 hours. Take a random sample of 30 batteries to measure their lifespans. Perform a two-tailed test. The null hypothesis is a sample mean equals 300 hours. The alternate hypothesis is the sample mean is not 300 hours. So in order to answer this question, what we're going to do is we're going to write a program in Python. And in order to write the program in Python, we're going to have to import some libraries. And these libraries are necessary to actually execute the program. So we're going to import NumPy as NP. So NumPy is a numeric library that performs numeric calculations. It creates NumPy arrays, and it also creates distributions. And then we're going to import scipy.stats as stats. So scipy is Python's scientific library. Stats is a statistical module within scipy. And then we're going to import matplotlib.pyplot as PLT, which it visualizes the data. Now what we're going to do is we're going to define our parameters. So the population mean is 300, the sample size is 30, the sample mean is 295, and the sample standard deviation is 15. The alpha is 0.05, and that is your significant level. So we're going to calculate the t-score. The t-score equals the sample mean minus the population mean divided by the standard deviation divided by the square root of the sample size. So I've already calculated the t-score here, and I got a t-score of negative 1.8257. And so now after we've calculated our t-score, then we're going to calculate the p-value for a two-tailed test. P-value equals 2 times brackets 1 minus stats.t.cdf, that's cumulative distribution function, brackets absolute value of your t-score, comma, df equals sample size minus 1. So df is your degree of freedom, and sample size minus 1 is 29. So then we're going to output the results is going to print the t-score, and we're going to print the p-value. And then what we're going to do is we're going to analyze the p-value. If the p-value is less than alpha of 0.05, we're going to reject the null hypothesis because the sample mean is significantly different from the population mean. If the p-value is greater than alpha of 0.05, then we're going to fail to reject the null hypothesis because the sample mean is not significantly different from the population mean. So we're going to plot the t-distribution, being x equals np.linespace, brackets -4, 4, 1000, y equals stats.t.pdf, and pdf equals probability distribution function, brackets x, df equals sample size minus 1, so df is, I think it's 29. And then we're going to plot the t-distribution. plt.plot, brackets x, y, label equals t-distribution, color equals blue. We're going to shade the critical region. Critical value equals stats.t.ppf, and ppf stands for percentage point function, brackets 1 minus alpha divided by 2. So that's going to be 0.95 divided by 2. Let me just think about this, because with the BIM-DOS brackets, exponents, multiplication, division, addition, subtraction, we're just going to say 1 minus alpha divided by 2 because it looks to me like it's alpha divided by 2 is 0.025, and then 1 minus alpha divided by 2 is 0.975, because that's just using the PEMDAS brackets, exponents, multiplication, division, addition, subtraction. And then your degree of freedom is sample size minus 1, and that's 29. So we're going to fill the critical region. PLT dot fill between brackets x, comma, 0, comma, y, comma, where x is less than or equal to negative critical value, or x is greater than or equal to critical value, comma, color equals red, comma, alpha equals 0.5, and then comma, label equals critical region. So now we mark the t-score on the plot. PLT.AX line brackets t-score, comma, color equals green, comma, line style equals dashed, comma, line width equals 2, comma, label equals t-score. So now we add our titles and our labels. The title is a two-tailed test. The X label is t-score. The Y label is probability density. And then you have a legend. And then so we're going to show it. So the t-score that we calculated is 1.8257. We look on my calculator and I got negative 1.8257. And then your p-value is 0.0782. So the p-value is above the alpha of 0.05. So we're going to fail to reject the null hypothesis. The sample mean is not significantly different from the population mean. And then we have a diagram of what we've done. So the blue line is your t-distribution. The red is critical region. And you notice that you got your red in 2 areas, and that's because this is a two-tailed test. And your t-score is negative 1.83, so your t-score is before the critical region, and since the t-score is before the critical region, then that means you fail to reject the null hypothesis. So that's it for this video. The next video we're going to be covering some more hypothesis tests, and I hope that you decide to watch it.